do a quick video on inverse functions and finding inverses. This is along about page 111, 112 in your notes. We're given a function f of x equals 5x plus 7. Show that it's 1 to 1. Well, if you graph it on your calculator, you'll see it's a line and it has a positive slope. To find out if it's 1 to 1, will it pass the horizontal line test? Yes, it will. No horizontal line will cross it more than one point. For the most part, any function that has an odd power, 1, 3, 5, 7, 9, and so on, will be 1 to 1. Evens will not, because you remember the evens look like u's. So here's the process to change any function or find the inverse of any function. So we have f of x equals 5x plus 7. So you change f of x to y. So you have y equals 5x plus 7. Then you swap the x's for your y's. So x will equal to 5y plus 7. And this is finding the inverse. And you solve for y now. Well, I want to get y by itself, so I have to subtract 7. So I have x minus 7 equals 5y. Well, then I divide by 5, which tells me that y equals x minus 7 over 5, which is equal to f inverse of x. And you'll find that if you put a value into f of x, and whatever number you get out, if you put that number into f inverse of x, you'll go back to your original number. That is the inherently what inverses do. We talked about them a little bit. We haven't really defined them when we're talking about logs and exponentials. Alright, so let's go through a couple of examples here of finding inverses. Well, this is an f of x, so we want to change it to a y. Y equals 2 over x plus 7. Well, to find the inverse, we're going to change it to x equals 2 over y plus 7. And then we're going to try to get the y by itself. So we have x minus 7 equals 2 over y. Well, I don't need this y. I don't need 1 over y. So I just need y. Remember, we can always look at an expression like this. So basically, we're going to cross multiply here. We're going to have y times x minus 7 equals 2. Now, don't distribute here because we want to keep that y separate. Well, now when we divide by x minus 7, then that gives us y equals 2 over x minus 7, which is f inverse of x. If you'll notice, anytime you're doing inverses, big picture look at it, we had a plus 7 here, so our inverse has a minus 7. We had a divided by x, so we're divided by x minus 7. That one maybe not as good an example. Okay, now here we're doing the same thing. Y equals 2 to the x plus 7. And to find our inverse, we have x equals, oops, not that, said it wrong. We have x equals 2 to the y plus 7. Well, the y is kind of by itself, but it's as an exponent. We have to remember what we're doing, or what we did earlier when we had an exponent we didn't want it. Well, we have to take the log of it. And we're going to take the log based off of whatever this number is here at our base for exponent. So we're going to do log base 2 of x equals log base 2 of y plus 7. Well, if we remember, log base 2 of 2 to the y plus 7. Log base 2 of 2 to the y plus 7. Well, that just equals y plus 7. So you subtract, and there is our inverse. So everyone's going to be the same. We switch the x's and the y's and we solve for y. If it's division, we're going to multiply, addition, subtract. If it's an exponential like this one, we're going to have to take a log. Well, this one has a log in it, so I would imagine that with a log we may have to use an exponential to get rid of it. So we're going to rewrite it as y equals, and to find our inverse we're going to change it to x equals 32 ln y plus 7. Subtract 32. Well, now we got this y with an ln. Well, the only way we can get rid of an ln is an exponent. This one is maybe not as intuitive, but we're going to use the base of e, and we're going to raise both sides to the same, or raise e to both, to put e as a base and use those both sides as the power. Can't speak today, sorry. Well, e to the ln of y plus 7, well, we should know by now that that just equals y plus 7. Well, and then when we subtract 7, that will give us y, which is f inverse. Alright, one more example on page 115. According to a study, this equation gives us the relationship between the amount of time spending, amount of hours spent studying, and T of x is the score on the exam. So T of x, y of x, P of x, f of x doesn't matter. To find the inverse, we rewrite it just like we have done, and then we find inverse, we switch x and y. So we have x equals 55 plus 17 ln x. Well, we need to subtract 55. So we have x minus 55 equals 17 ln x. We only divide by 17. So we have x minus 55 over 17 equals ln x. Well, to get rid of this ln x, we take everything and raise it up and use e as the base and use that as an exponent. So we have e raised to the x minus 55 over 17, all that is an exponent, equals e to the ln x, which just equals x. And that should be y. I've been saying y. This is y, y, y. So y equals e x to the minus e raised to the x minus 55 over 17. Very messy, I'm sorry. So the expression for T inverse is e x minus 55 over 17. So evaluate this inverse at 90. So what we do is we basically plug in 90 to the function we just found. So it's e raised to the 90 minus 55 over 17. And that gives us 7.837. And the function itself took our study and gave us a score. Well, the inverse function will give us a score and give us a prediction for our studying. So what this result means, is a student that scored 90 on the exam, studied or is predicted to study for 7.837 hours. There you go.